All right, so y'all go ahead and do the factoring and the math launch question for day. Pause the video, and then once you're finished, you can unpause it, and I'll go over the correct answers. So the way that you're going to factor this, both of these two terms have an x squared in common, and if you pull that out, you're left with 4x minus 1. And then we can factor out a negative 1, and we'll be left with 4x minus 1 in the second set. So we can rewrite that as x squared minus 1, and then 4x minus 1. X squared minus 1 can be factored as x minus 1 times x plus 1, and then we have our 4x minus 1. And so that would be your factoring answer for today. For the math knowledge question, all it's asking about is the quadratic formula. Well, negative b plus or minus the square root of b squared minus 4ac all over 2a. That is your quadratic formula. So our b is a negative 5. So we are looking for a negative 5. Well, that is a positive 5, so that automatically eliminates C, G, and E. So we have 5 plus or minus, negative 5 squared is 25, minus, oh, that one's a minus, that one's a plus. So there's our answer right there. We don't have to go any further. So those are your answers for those two. So we're looking at lesson 76 today. We're dealing with integration of odd powers of sine and cosine. So we're going to be integrating these today. Hopefully you'll understand it after this lesson. So we want to integrate sine cubed of x dx. Now you may think that all it is going to be 1/4 sine to the 4th of x plus c. However, if you take the derivative of that, 1/4 and 4 are going to cancel, and you're going to have sine cubed x. And then you have to take the derivative of sine, which is going to give you a cosine. Well, if you look up here, we don't have a cosine. And so that's not how you're going to do those. All of the problems that have been set up like this have had that cosine or the sine right behind it in the original problem, and so that's why you've been able to do what I just wrote. But that's not how this one is going to work. What you're going to need to do instead is to split up sine cubed into sine squared and sine. We're basically going to make that second part where we have our sine or our cosine in the problem. And so sine squared, using your Pythagorean identity, is the same thing as 1 minus cosine squared. And so now, if I distribute that sine dx, I'm going to have sine x minus cosine squared x sine x all times dx. And so now we can actually integrate each part separately. So the integration of sine is negative cosine. And on this one, we can actually do what we were going to try and do possibly earlier. The integration of cosine squared, we can write as 1/3 cosine cubed. And I left the sign blank because I want to see, is it a positive or is it a negative? Well, if I take the derivative, I would have the 1/3 and the 3 cancel, and then I'd have cosine squared x, and then the derivative of cosine is negative sine x. So I need to make this a positive right there. And then I need to add my plus c. Okay, so you had to have a positive here so that whenever you took the derivative and you have a negative right here, it stays as a negative. If I put a negative sign right here, then I'd have a negative and a negative, which would have made a positive. And so that's why you want to have a positive sign here. Okay, so now let's look at one like this, where we have cosine cubed. we're going to do the same sort of thing. We're going to start by splitting it up into cosine squared x times cosine of x. And so the cosine squared can be written as 1 minus sine squared. And then we have times cosine of x dx. So we're going to distribute our cosine of x. So we have cosine of x minus sine squared x cosine x, all times dx. And so now we can integrate. Well, if you integrate cosine, you get sine. And if you integrate negative sine squared, well, we're going to have a 1/3 sine cubed. And if I take the derivative, I'm going to have sine squared x times cosine of x. So I need this to be a negative since this sign right here is a negative. And then I put my plus c, and that would be your answer right there. So these aren't just, oh, add 1 to the exponent and multiply by the reciprocal. That's not what these look like. So now let's look at another example where we have both a sine and a cosine. We've got sine to the 4th and cosine to the 3rd. What you want to do is to break up the factor that is raised to an odd power. The one that's raised to an odd power is the cosine. So that's the one we're going to break up. So we're going to have sine to the 4th, cosine squared, and cosine. And I can rewrite cosine squared as 1 minus sine squared. And I'm going to put it in front just so that it's a little bit easier to distribute the sine to the 4th cosine x into the 1 minus sine squared. So if we distribute, we'll have sine to the 4th times cosine minus sine to the 6th times cosine, all times dx. So now we're going to integrate. If we integrate the sine to the 4th cosine x, we're going to get 1/5 sine to the 5th x. And if we integrate sine to the 6th times cosine, we're going to have minus 1/7 sine to the 7th of x plus c. Okay, and so that would be your answer for that problem. Looking at the next example. I just told you when you had 2 of the powers to pick the odd one. Well, on this one, they're both odd. So what you want to do is to pick the odd one that is smaller, which is going to be the sine cubed. So we're going to write it as sine x times sine squared times cosine to the 7th x dx. And so we'll have 1 minus cosine squared instead of our sine squared, and then sine x, and then cosine to the 7th x dx. So now we can distribute, and we'll have cosine 7 sine minus cosine to the 9th times sine, all times dx. So now we're going to integrate, and whenever you're integrating cosine, it's going to change sign, so it's going to be negative 1/8 cosine to the 8th of x, and then plus 1/10 cosine to the 10th of x, and then plus c. And so that whole thing will be your answer there. So now we're going to look at another example. We've got the integration of sine squared times cosine to the 5th. So we have to split the cosine up because it's the odd one. But I'm going to actually have to split it into cosine squared times cosine squared, then times cosine. I've got to split it into 3 separate pieces. And then you are going to replace both the cosine squareds with 1 minus sine squared. we have cosine x dx. So now I'm going to go ahead and distribute this part here, and I'm going to leave the sine squared x and the cosine x dx at the end. I'm going to have 1 minus 2 sine squared x plus sine to the 4th x all times sine squared x cosine x dx. Okay, so now I can distribute, and I'm going to end up with sine squared x times cosine x minus 2 sine to the 4th x cosine x plus sine to the 6th x cosine x all times dx. And so at this point we can integrate each of those 3 pieces. So the first one is going to integrate as 1/3 sine cubed x, and then we're going to have minus 2 over 5 sine to the 5th x, and then plus 1 over 7 sine to the 7th x, and then plus c. And so that would be your answer for that problem. So the key to integrating odd powers of sine and cosine, you have to split up your odd power into squares, and then take your squares and replace them with your 1 minus sine squared or your 1 minus cosine squared. And then from there, you're just going to multiply until you get it all distributed out, and then you're going to integrate. The signs on the sine of x are going to stay the same. The signs on the cosine of x are going to change. So if they were negative, they're going to become positive, and vice versa. So hopefully that helps you with the integration of odd powers of sine x and cosine x. On your homework, you do get to omit number 10, 12, and 18. So make sure to do that tonight so that tomorrow we can go over any questions that you have.